error is not quite what we want. Welcome back to Ngrx4 and Angular Reactive Development from Pluralsight. My name is Deborah Kurata, and in this module we examine techniques for mapping return data. We may have a stream like this, but what we want is a stream like this. We transform items in a stream from apples to apple juice using mapping. There are many reasons to map the data returned from a backend server. To modify a value, for surge pricing we increase the prices by 50%. To transform a value, changing Y to true and N to false for easier binding, or changing prices to a different currency. To change field names, a legacy backend system may return P_NM as a field name, but we'd rather work with the field as product name. To add a calculated field, for example, calculating a profit to display in a view. Use mapping anytime you want to modify the values, fields, or shape of the return data. But simple mapping doesn't always work with data retrieved from a backend server. In this module, we look at the nuances of mapping data returned in an HTTP response, and we examine how to map elements from an array emitted by an observable. The Ngrx4 features demonstrated in this module include more examples of the map operator. Let's get started. Earlier in this course, we transformed each item emitted from an observable using the map operator. In the function passed into the map operator, we multiply the value of each item by 2 and log it. Let's try something similar with the response returned from an HTTP GET request. We are back in VS Code with the APM folder open. Here in the product service, we have the observable property we defined in the last module. Let's confirm the type of this observable by hovering over products $. We see that its type is an observable of product array, so it's an observable that emits an array of products. We want to uplift our prices by 50% for search pricing, so let's use the map operator to multiply each product's price by 1.5. We specify the map operator and use the quick fix to add the associated import. We map the item, access the item's price, and multiply by 1.5. Wait, that doesn't work. If we hover over item, we see that we are piping the entire array through the map operator, not each array element. Why is that? Before we answer that question, let's comment out our new code to resolve our syntax error. When we issue an HTTP GET request asking for a single item, such as a product, we receive a single response containing that item. The HTTP client service automatically maps the response to the defined shape, which in this example is the shape we specified in the product interface. When we subscribe to this observable, it emits one item, the product. But often we issue an HTTP GET request asking for a set of items, such as all products. We still receive a single response, but that response contains the set of requested items. The HTTP client service automatically maps the response to the defined shape, which in this case is an array of items shaped as specified in the product interface. When subscribed to, the products $ observable emits one item, the array of products. Note that these are not instances of a product. They are items shaped as defined by the product interface. If the fields returned in the response don't match the defined shape, you are not notified. The fields from the response are simply merged with the fields from the interface. We've compared an observable stream to a conveyor of apples. That's accurate when working with simple observables. When retrieving a set of data using HTTP, the returned observable is more like this. We receive one item, this box, which represents the array emitted by the HTTP response. So we can't use simple mapping techniques. If we need to modify every element in the array returned in the HTTP response, we first map the emitted array, then map each element in the array. Lastly, we transform each element. Here we modify each apple, affixing a label. Let's walk through this process, taking it one step at a time. The first step for working with a set of data returned in an HTTP request is to map the emitted array. In this example, it's an array of products. We then process that array as needed. Let's give that a try. Looking at the product service, let's map the array emitted from the observable returned by the HTTP GET. For now, let's just return the products. We are retrieving a set of products, so HTTP GET returns an observable that emits an array of products. We use map to map that array. Hovering over products $, we see that we have an observable that emits an array of products. Checking it out in the browser, and we still see the data, but we aren't yet processing the items in that array. Now that we've mapped the emitted array, we map each element in that array. Because we've mapped the array, we can use the arrays map method to map each array element. The map method loops through each element of the array, processing it as needed. Let's give that a try. Looking again at the product service, we use the products array map method to access each array element. Since we can access each element, let's again try to uplift the price by 50% and delete our prior map operator. Looking at the browser, we don't see any data. Let's check the console. After piping the products through our operators, we have an array of numbers. How did that happen? Looking back at the code, the array map method processes each element in the array according to the provided function. Here we transform each product to a price. That's not what we wanted. And a tip here, one quick way to see if you're getting what you expect is to hover over the observable property. We see observable of number array, so even without running the application, we know something's wrong. How do we fix this? After we've mapped the emitted array and mapped each element in the array, we transform each array element. We transform each array element inside the map function. In this example, our goal is to transform each product in the array. To accomplish our goal, we map each product to a new product, keeping the parts of the original product that we want and replacing the parts we want to change. We define a new object literal using curly braces. Because this is an arrow function, curly braces define a function body. To disambiguate the braces, we add parentheses. Inside the object literal, we define properties for the desired new product shape and set the value of each property using values from the original retrieved product as needed. Here we increase the price, multiplying it by 1.5. And we add an additional property, search key, setting it to an array initialized to the product name. To ensure we keep things strongly typed, we add as product to type the object literal. So our map transforms our original product to a product with a new structure and assigns the original values into that structure with updates to those values as needed. But this looks like a lot to type. Is there an easier way? Yep, we can use the spread operator. The 3 dots here is the JavaScript spread operator. It copies all of the properties and values from the specified object to the new object. Basically, it's a shortcut for this syntax. Then we only need to specify any modified or additional properties or values. That looks better. Let's jump back to the demo. In the product service, we'll change the map function to copy all of the product properties and values, and then adjust the price. We define an object literal using curly braces, and use the spread operator to copy the product's properties and values. We are getting all sorts of syntax errors here. Any idea what we forgot? An arrow function assumes curly braces define a function body. We instead want an object literal, so we add parentheses around the curly braces. That's better. Now we only specify the fields we want to modify. We set the price to the uplifted price. Our product has a search key array. Let's populate the first element of the search key array with the product name. That's it. Our transformation is complete. Hovering over the product's dollar property, we see that we have an observable that emits an array of a bunch of properties. Our component is expecting an array of product. To ensure we strongly type the result, let's add as product to cast the new object literal to the product type. Hovering over the product's dollar property again, we see we have an observable that emits a product array. Now that we have all of the code in place, let's walk through it. We're retrieving a set of products, so HTTP GET returns an observable that emits an array of products. We use map to map that array. In the map function, we use the arraysMap method and map each product in the array. To transform each product, we create a new product using an object literal. The spread syntax copies the properties and values from the original object, and we only change properties or values as needed. Checking it out in the browser, we see the uplifted prices. Yay! But notice our category here. Our product data provides the category as an ID. Do our users know what category 3 means? It would be nicer if we could map this ID to a user-friendly string. We'll do that in the next module. For now, let's finish up this module with a brief summary and checklist for using the features we've covered. When using HTTP GET to request a set of data, it returns an observable that emits an array. To perform an operation on the elements in that array, map the emitted array. Then use the arraysMap method to iterate through each individual array element. Lastly, transform each array element, modifying the value, property, or shape as needed. Mapping the emitted array involves using the map operator. Mapping the array elements leverages the arraysMap method. To transform each element, define an object literal of the desired type. In our example, the input type is a product and the output type is a product, but they don't have to match. You could map to a different type. Leverage the spread operator to copy the properties and values from the input type. Replace property values or names and add properties as needed. Use the as clause to type the result. Next up, let's look at combining multiple streams for more complex mapping scenarios. Datasets by combining their observable data streams into one stream. Welcome back to RxJS and Angular Reactive Development from Pluralsight. My name is Deborah Kurata, and in this module, we combine the streams. Our stream of apples looks delicious, but if we merged our apple stream with this, a stream of sticks, our resulting stream could be this. Tasty. Why combine our observable streams? To map an ID to a string. Merge a data stream with a lookup data stream to map IDs in the data to their associated strings for a more user-friendly display. Combine streams to work with multiple data sources and provide more useful and comprehensive information. For example, combining product data with supplier data to display the available suppliers for a product. Stream composition enables us to create complex queries across multiple data sources. Combine streams to react to actions. Merge a data stream, such as products, with an action stream to re-execute our operator pipeline anytime the action occurs. For example, to refilter a list of products each time the user changes the filter criteria. And combine streams to simplify our template code by merging all the streams required for that template. Then we only need one async pipe. We cover this first scenario in this module and the others in later modules of this course. In this module, we examine key RxJS operators for combining streams. then walk through how to combine streams to map an ID in the data stream to a string using a stream of lookup values. The Ngrx4 features demonstrated in this module include combine latest, fork join, and with latest from. Let's get started. As the name suggests, the Ngrx4 combination features combine information from multiple observable streams. There are several types of combination operators and creation functions. One type combines items from multiple streams into a single stream. Here, the stream of letters is merged with the stream of numbers into a single stream of letters and numbers. Merge and concat are examples of this type. This type is often used when the data is uniform. Another type combines complex observables, an array for example, into a single flat stream. Hence, operators of this type are often called flattening operators. Here, the elements of each array are merged into a stream of all array elements. The merge all operator is an example of this type. The last type are those that combine values from multiple streams, emitting an array of combined values to the output stream. Here, when the A and 1 are emitted, an array is emitted containing the values A and 1. In this module, we focus on this last type and look at combine latest, fork join, and with latest from. Let's start with combine latest. Latest values from each input observable. Here we combine 3 streams and create one stream that emits an array with the value from each of the combined streams. Combine latest is a static creation function, not a pipeable operator. Think of combine latest like an auction house that takes bid from the audience, online, or on the phone. Anytime any of the streams emit a new value, the new bid price is emitted. But notice the shape of the emitted data. It contains the last emitted value from each of the streams, in order, in an array. Since we have 3 streams, we have 3 elements in the resulting array. So when the 75 is emitted, it takes the latest value from each stream, this 50, this 55, and the 75. It looks like we're missing some values in our output stream. That's because, unlike a real auction house, combine latest doesn't emit anything until all of the streams have emitted at least one value. The second stream doesn't emit until here. Waiting for all streams to emit at least once ensures that the output array always contains the same number of elements. But it also means that some emitted items may be dropped from the combined stream. More formally, combine latest is a combination creation function. It takes in a set of observable streams as an input, subscribes to each, and creates an output stream. When an item is emitted from any of the streams, if all streams have emitted at least once, it emits a value to the output stream. It completes when all input streams complete. The value emitted to the output stream combines the latest emitted value from each input stream into an array. Use combine latest to re-evaluate state when an action occurs. By combining a data stream, such as a list of products, with an action stream that watches user actions, such as a filter selection, we can re-evaluate the state each time the action stream emits and filter the list. We'll see an example of this a little later in this course. Next, let's look at fork join. Fork join creates an observable whose value is defined using the last value from each input observable. Notice I said last and not latest. Here we combine 3 streams and create one stream with the last value from each of the combined streams. Fork join is a static creation function, not a pipeable operator. Fork join only cares about the last value in each stream. It's like deciding how to paint your house. You emit several color choices, your partner emits several color choices, and your neighbor emits several color choices. You don't paint the house each time someone suggests another color. Rather, you wait for the last emitted color choice. But again, notice the shape of the emitted data. It's an array with the last value from each of the streams. More formally, fork join is a combination creation function. It takes in a set of observable streams as an input, subscribes to each, and creates an output stream. When all input streams complete, it emits a value and completes. The value emitted to the output stream combines the last emitted value from each input stream into an array. Fork join is often used when you need to execute several HTTP requests and don't want to process any results until all requests are complete. Since fork join only emits when all input streams complete, don't use fork join when working with streams that don't complete, such as action streams. With latest from is next. With latest from creates an observable whose values are defined using the latest values from each input observable, but only when the source stream emits. Here we combine the source stream, $, with two other streams to create one stream with values from each of the combined streams. But it only emits to the output stream when the source stream, $, emits. With latest from is a pipeable operator. We have three streams: apples, which is our source stream, sticks, and caramel sauce. When the apple stream emits, we get the latest emitted stick and caramel sauce from the other streams and emit the candied apple. It looks like we are missing some values in our output stream. That's because with latest from does not emit until all of the streams have emitted at least one value. And then it only emits when the source stream emits. That occurs here and here. More formally, with latest from is a combination operator. It takes in a set of observable streams as an input, subscribes to each, and creates an output stream. When an item is emitted from the source stream, if all streams have emitted at least once, it emits a value to the output stream. It completes when the source stream completes. The value emitted to the output stream combines the latest emitted value from each input stream into an array. Use with latest from to react to changes in only one of the streams, or to use the source stream to regulate the output of the other streams. Let's look at a more real-world example of combining streams.